Hello. As I promised, I'm going to show you how to work on Excel. And this is the real data I used for the example. So here, Mongolia, Russia, Canada, Norway, like that. There are 183 countries. So, and we have average yearly temperature Celsius and GDP per capita in purchasing power parity, constant 2005 international dollar. So the first thing I want to show you is I will show you how to make a scatter plot. It's simple. Insert and here click scatter. So this shows scatter plot options, and you may choose different options, but usually this is what you want. So it's simple, like as simple as this. And from here you may change options and decorate the graph, which is not what I want to I'd like to show here. Okay, and then now the next what we are going to do is we are going to calculate the covariance and the correlation coefficient. The formula, insert function. In case if you do not know what is the function, you can simply do it like this. Covariance, when you search for covariance, there are three options. This is maybe outdated, I think. Compatibility with Excel 2007 or earlier. So it's outdated. And there are two options, covariance P, covariance S. So this is sample covariance function formula, and this is population covariance formula. I will show you one by one. So let's first do population. Then array 1 is the array of the first variable, right? Of course, I drop the label. And array 2 is GDP per capita. So choose like this, right? And then click. The covariance is minus 36,000, which is a huge number, but means nothing. It's just a negative number. That's it. And this was, by the way, population covariance, right? And if you calculate sample covariance, you may I will type things. If you type the formula like this, then you will get different number, slightly different number. Of course, the overall, like the sign should be the same, but slightly different. Sample and population variance. You may but sample covariance is more commonly used. And now, correlation coefficient. If you want to find correlation coefficient, you use this. The structure is the same. COR, let's put it this cell. Correlation, correl. So from P and from S. These two columns are considered as for the correlation coefficient. Then you get minus 0.31, so about 31% correlation coefficient. By the way, there is no sample or population formulas for the correlation coefficient because, remember, correlation coefficient is the ratio between covariance divided by standard deviation. And if you use population covariance, the denominator, the standard deviations, must be calculated based on the same type of formula, population variance formula. if the numerator was sample formula, denominator should be sample formula 2. So, and in the end, then both will be the same. I will show you how that works. So, standard deviation, temperature, standard deviation, population, temperature. And I will calculate standard deviation, population, GDP per capita, standard deviation, sample, G. So let me calculate standard deviation for each variable to show you how standard deviation sample, excuse me. So again, the standard deviations are slightly different if you use whether you use population or standard sample, and we'll do the same thing. So like this. Did I do something wrong? It was wrong. So this is basic, like more fundamental way to calculate the correlation coefficient. Let me calculate the correlation coefficient using population formula. Population covariance divided by population standard deviation times population standard deviation. This. And now sample covariance divided by sample standard deviation times sample standard deviation. Same thing. So, excuse me, correlation coefficient does not change depending on which formula you use. So as long as you match the formula for the covariance and the standard deviation. So this is a simple way to calculate them. And now you may just try the same thing for Fahrenheit. Now I made up new variables in Fahrenheit and in same dollar. So I changed the temperature only. And let's try. Everything else is the same. So covariance, population covariance is now minus nearly 66,000. Compared with this, it's much larger. But what you can see here is, remember, it is multiplied by 1.8. 1.8 is the multiplied number between Fahrenheit and Celsius. So if you compare this, 36653, same thing, right? So the formula we learned in the slide verified. Sample covariance can be done in the same way. So, and you may check if they are the same, right? These two numbers are the same. And then how about correlation? Correlation coefficient is the same. So even though covariances are different from the earlier unit, but correlation coefficient does not change after unit change. So which is exactly what we learned in the slide. And now here, this is the second example, macroeconomic variable, real GDP growth, industrial production growth, CPI inflation, unemployment rate, and 10-year treasury bill rate. So it's real data, US data, from 62 through 2015. And I would like to make the covariance matrix. To do that, first you have to have something here. Actually, you have to install add-on. Let me add-on. It should be should be here. Analyze add-on should be here, but I have not installed it yet. Let me show you how to install the add-on add-ins. And here, analysis toolpack, install that. If you install, it takes time. It should come up here. Let me check it. Why does it go? Here, go, and check it. Then it will be installed, and you see a new package added here, add-on added here, and click this. And after clicking that, what you can see here is we are going to use these two, covariance and correlation. Let's do covariance first. If you use covariance and then input range, I will choose from here to here 5 columns. Like there are more than 200 observations, and label in the first row. And if like variable is grouped by columns, so I will first row has label. I will click OK. OK. Then you have a table. This is the same table you see in the slide, right? It is a covariance table. It is the covariance table. And if you want a correlation coefficient table, excuse me, it's not this one. Data tab, data analysis tab, and correlation. And same thing. Choose, drag from here to here, for example, and okay. Then correlation coefficient is given by the table. Now I did not choose the variable name, so the names are gone. This is a simple way to calculate multiple correlation or covariance in one click. And this data analysis toolpack is pretty useful. Like ANOVA, if you have learned like statistics from like elsewhere, then maybe you have heard about ANOVA. Histogram can be calculated here, and simple descriptive statistics can be calculated here. Regression is what we're going to do in the next chapter, and some test, z-test, can be handled in here. Okay, I hope this is useful for you, and we will finish the call it a lecture. And next lecture I'm going to continue chapter 11. Okay, see you later. Bye.